This video shows what PyKale looks like. Here is a snapshot of the Kale API. There are 8 modules. 6 of them are the 6 steps in our standardized pipeline. Load data, pre-process data, embed, predict, evaluate, and interpret. There are 2 additional modules called pipeline and utilities. Here is an example of the first step, load data, and this is what it looks like. This is a utility module, and this is the pipeline module containing mature and highly reusable pipelines. We built standardized examples with the code and configuration separated. The configuration defaults are defined in config.py, and it can be customized using YAMLs in this folder called configs. We standardize the example so that the same file name, the same module, will have the same functions. So that when we move from one example to the other examples, the same files have the same meaning, right? So you don't need to learn additionally what the different files means. So they all have the same meaning. So we standardize the file names across all examples. So here is an example of the configuration of our machine learning modules. This is the default settings in the config.py. For example, here is a configuration for the data set. You define where the data, what is the name and the dimension, number of classes, and so on. And this is about optimizer, the learning rate, seed, and so on. And these are the default settings, which will be typically fixed. And if we want to have customized configurations, we define separate YAML files. And these are 2 examples. At runtime, this will be merged with the default setting to have the customized file setting. We have built many community engagement features. We have comprehensive documentations on Read the Doc. We have detailed contributing guidelines from light involvement to heavy involvement. We have a project board set up where everybody can see our to-do list and the progress, as well as the overview, for example, the roadmap and so on. We also set up a discussion board where everybody can post a new discussion and we can answer to offer help. We also release YouTube videos on YouTube so that there will be a more preliminary introduction to our package. We also have written a paper, a 10-page paper, and post it on archive as a preprint. We prepared 3 Jupyter notebook tutorials, and you can run these notebooks without any installation. You can do so, use Google Colab if you have a Google account. Otherwise, you can run the notebooks using MindBinder. So I will show you a demo. So here is the homepage for our repository. And you can move down to how to use, and the step 1 are the tutorials. And let us start with a basic example of digit classification. So you can run this example in Google Colab by choosing a free GPU. and then we run all, and you click run anyway. Then the notebook will do the setup, which are the installations, and run this example. Right? So you see now it is doing the installation. Right? Download the package and do the installation. Right? So we can come back to this later. So you can also run this using Binder, right? Which is a bit slower. Right? So that is Binder. So these are the tutorials, right? So this is working, right? So now let's go back to the slides. So in the current version of PyKale, we have built support for graph, image, text, and video. In terms of machine learning models, we focus on first transfer learning, and in particular, we focus on domain adaptation. And the second focus is multimodal learning, where we aim to provide support for integration of heterogeneous data. That's why we started with building support for individual data modalities, including graph, image, text, and videos. We have deep learning modules built in, including convolutional neural networks, graph convolutional neural networks, and transformers. We also build in tensor-based dimensionality reduction APIs. Our current examples have span several applications. Firstly is image and video recognition, including CIFAR digits or face videos. And we also have examples for bioinformatics applications and graph analysis, including applications on BindingDB and knowledge graphs. We also have example applications on medical imaging applications, such as cardiac MRI diagnosis. Let's go back to the example you see here. That is, see, we finished the installation over here. Then that's the installation, right? So finish the installation. And that is the configuration. That is the customized, this is the merge of the configuration customized with the default. And then we show what is the configuration after the merge. And then you see we are using CUDA, we are using GPU. And then we choose a simplified data set, set the seed, and set up the model. This is download the data set from the host, set up the logger, set up the checkpoint, set up the trainer, GPU available true. And then we start the training, right? So this is the most costly step, but using GPU, right, it takes 1 or 2, maybe around 2 minutes. So we run for 3 epochs, and now it is running the last epoch, right? From 0 to 1 to 2. After finishing this epoch, then the model has been trained, then we will test it on the test set. So you can see some information about the model as well, right? So that is some very basic information. There are 466K training parameters, right? So then you see it finish. It takes about 1 minute, 42 seconds for the training. And the testing is very fast, right? So here we have the target accuracy about 46% for 3 class classification, right? So here we are aiming for speed, right? So therefore we simplify the example. The model is not fully trained, so it just shows that it works, right? But it's not the best result is possible. Usually you need to train it for like 100 epochs to get the best result. Here we just train it for 3 epochs, right? So for the binder, it's a bit slow, right? So it's still doing the installation. So we will not come back again to the binder. Okay, so that is what PyKale looks like, right? So by now we have answered the why, how, and what of PyKale. In the next video, I will do a summary.